Calculate the average atomic mass of bromine. One isotope of bromine has an atomic mass of 78.92 AMU and a relative abundance of 50.69%. The other major isotope of bromine has an atomic mass of 80.92 AMU and a relative abundance of 49.31%. So to solve this using the equation, first thing I did, I highlighted my isotopes in different colors. This is just to prevent us from mixing up our numbers, so we don't want to put the wrong mass with the wrong percent. So basically what we need to do, and what you need to remember, is that you have to take the decimal percent of isotope A and multiply it by the mass of isotope A. So this calculation here, you're going to repeat for however many isotopes there are. So in this case, there's only 2 isotopes. So I'm going to do it for isotope A, and then I want to add that to the same calculation, but this time for isotope B. So the decimal percent of isotope A, so it's 50.69%. So if I write this as a decimal, I'm just going to divide by 100, which is the same thing as just moving my decimal over twice. So that gives me 0.5069 times the mass, which is 78.92 AMU. And now I just got to repeat the exact same calculation, but this time I'm using my numbers for isotope B. So isotope B has a percent abundance of 49.31%. So if I move the decimal over twice, divide by 100, that's what I get. And the mass is 80.92 AMU. So plug this into your calculator, you're going to get 2 numbers. So I get 40.004548. And I'm writing out all of these decimals because we're going to have to round this to the correct number of sig figs, and we haven't figured out how many that is yet. So we're just going to write out the whole thing. So my rough algebra, once I add these together, I get 79.760544 AMU. Okay, so now we've got to figure out our number of sig figs. So our first step was to multiply these 2 numbers together. So this has 4 sig figs, this has 4 sig figs, so the answer here would have 4 sig figs. Then I add these numbers together, and whenever I do, because my answers here are going to have 2 decimals, I need to, whenever I add them together, have 2 decimals. So whenever I round this to the correct number of sig figs, it becomes 79.76 AMU, atomic mass units. And then we can check on our table of elements, so we can find bromine. Bromine is 79.904, so that's pretty close. So maybe we had some rounding, or maybe the numbers that I put out here weren't that precise, but we still get roughly the same answer, so we know that we performed this calculation correctly. Okay, the next problem, there are 2 naturally occurring isotopes of gallium. There's gallium-69, which has a mass of 68.93 AMU, and gallium-71, which has a mass of 70.92 AMU. So what I want you to do, without any calculations, look at the table of elements and determine which is more abundant. So our 2 isotopes, we've got the gallium-69 with this mass and gallium-71 with this mass. So gallium comes in 2 flavors. There's 2 isotopes of gallium. So one option is gallium-69. So gallium-69 has this mass. The other option for gallium is going to be the gallium-71, which has a different mass. So these 2 numbers are slightly different, and what I'm really asking you to do is to look at these 2 numbers and figure out which one is closer to the average value on the table of elements. So if we look up the actual mass for gallium, we see that the actual mass is 69.72 AMU. So this number was found by taking some weighted average of these two numbers. So whichever one of these two numbers is closer to my weighted average, that must be the one that is most common. So in this case, we see that the gallium-69, this mass is closer to the actual mass. So the one with the higher abundance is going to be the gallium-69.